Good day, grade 12s. Today we will be covering our first lesson under sequences and series. And our topic for today is arithmetic sequences, which I will be dividing up in 4 parts. So the first part will be about finding the general term of an arithmetic sequence. The second part will be about finding the value of a specific term. The third part will be about determining which term is equal to a specific value. And the last part is a favorite question that examiners like to ask. And that question is, how do we calculate how many terms there are in a sequence? So how do we find the general term of an arithmetic sequence? Now, an arithmetic sequence is simply a linear number pattern. In grade 12, we have this formula on your formula page, which represents the general term of an arithmetic sequence. Tn over here refers to the general term or the nth term, which we are looking for in this case. A refers to the first term. And this d over here refers to the common difference, which is normally term 2 minus term 1. So let's do an example where we find the general term. So this question says, let's find the general term for the sequence. Our sequence is 5, 8, 11, and 14, and so forth. And we can see this is an arithmetic sequence because we are adding 3 the whole time. So there's a constant difference of 3. So I'm going to show you what steps to follow to find the general term. We can do inspection where you just see the general term, or we can use the formula on our formula page. And I think I'm going to do that one with you today. Step number 1 to finding the general term is I write the formula down from my formula page. Step number 2 is to substitute A and D. Now remember I told you A is the first term. So A is 5 because 5 is our first term. And D is our constant difference. I told you D is T2 minus T1. So D is 8 minus 5, which is 3. So I'm going to substitute A and D now. So that's step 2. So I'm going to write T in, general term, is equal to A becomes 5 plus N minus 1, D becomes 3. So there's an invisible dot there actually, eh? So the general term, I'm going to simplify now. This is 3 times n is a plus 3n. And 3 times negative 1 is minus 3. And now I'm just going to add the like terms. 3n, 5 minus 3 plus 2. And that is the general term. So that is part 1. This is how you find the general term of an arithmetic sequence. An arithmetic sequence is a linear number pattern. Let's go to part 2 of our lesson. Part 2 is about finding the value and finding the term itself, the value of a specific term. Look at this example. It will look familiar. We've done it before. So using the same sequence, let's find the 10th term. I write my general term down, which I found in the previous question. Instead of writing n, I'm going to replace n with 10 because I want T10. 3, there's an n, so I'm going to make it 10 plus 2. So the 10th term is 30 plus 2. That means the 10th term is 32. The second method is helpful if you don't have the general term. So if I don't have the general term, I'm still going to copy the formula from the formula page. So let's say you did not find the general term. You copy the formula from your formula page and you are still looking for T10. So I'm still going to make n 10. Now I'm going to replace A, N, and D. So I'm going to replace A. A is the first term. N, I'm looking for the 10th term. D is the constant difference that we worked out, and that was 3. So now I'm going to replace all those variables. So A, first term, is 5. N is 10. D is 3. So T10 is 5 plus 10 minus 1 is 9. Keep it in a bracket times the 3. So T10 is 5. What's 3 times 9? 27. T10 is 32. The first way is when you have the general term. The second way is when you just want to use the general term from your formula page. Part 3 is about determining which term is equal to a specific value. So which term? I want you to highlight which term here. If they ask you which term or the number of terms, you must always remember that you are going to solve for n. We are going to solve for n. So I'm going to show you two ways again to do this question. Let's split up the page again. The first method that I'll be using is I'm going to take the general term again that I worked out. So remember, the general term is 3n plus 2. So we want to know which term is equal to, in the sequence, 5, 8, 11, 14, and so forth. We want to know which term will have a value of 47. So here we have the value. We want to know which term is equal to 47. So method number 1, I'm splitting the page in two parts again. I write the general term down that I worked out. This Tn, I'm going to make it equal to this 47. So now I say 47 is equal to 3n plus 2. And now I do algebra by isolating n. So I get n by itself. So 3n stays there. 47 minus 2. This becomes 45. To get n by itself, you divide by the number in front of n. So divide by 3 on both sides. I get n to be 15. So how do I answer the question? I will say T15 is equal to 47. That's method number 1. If you don't have this general term, let's say you don't have it, you can use the formula from your formula page. So I'm going to write the formula down. And this Tn will be this 47 over there. So 47. And now I replace A. I don't replace N because I don't know what it is. And I replace D. So I only replace A and D because I'm working out N. A is the first term, which is 5. I don't know what N is. D is the constant difference, which is 3. 3 times negative 1, negative 3. 47, can you see I still have the general term? Like terms plus 2. Take the 2 over. This is 45. Divide by the number in front of n. Divide by 3. N is 15. Therefore, term 15 is equal to 47. Okay, that's how you do a question like that. So here we are at the last part of our lesson for today. We give you the pattern and we give you the last term in the pattern. So the last term is normally given and we will ask you how many terms are in the sequence. So we're using the same pattern and we are asking how many terms are in the sequence if the last term, can you see, there's no dot after that. So that means 25 is the last term. So I'm going to show you two ways to do it again. The first way is I write the general term down. In this example, I'm going to make the general term equal to the last term. So if I want to know how many terms there are, I make the general term equal to the last term and I solve for n. 3n stays there. 125 minus 2, 3n, 123. Divide both sides. Not by 123, but by the number in front of n. So divide by 3. 3, I get my n to be 41. So there are 41 terms in the sequence. Okay, that's one way. Let's say you did not know that this is the general term. Then you write the formula down from the formula page. This Tn you make equal to the last term. So 125. I'm only replacing A and D because I am looking for n. A is 5. D is 3. 125, 5 plus 3n minus 3. 125 is equal to 3n plus 2. There's the general term. And then 125, bring the 2 over, 3n, 123. 3. 3 in, divide by the number in front of in. I get my in to be 41. There are 41 terms in the sequence. Thank you so much for joining me.